So initially, if we start the Teradata introduction, right? Teradata is nothing but it's an RDBMS. It's just like another relational database management system, like Oracle DB2 SQL Server. But it has been designed to run one of the world's largest commercial databases. Basically, it came into the market only for large systems, not for small or medium scale systems. And it is a very good solution for enterprise-wide data warehousing, and it is an open system. Why we call it as an open system is it can run on multiple platforms, like multiple operating system. Initially, 6 to 7 years back, right, 90% of the clients were running Teradata on MPLAS operating system. MPLAS is a flavor of Unix operating system. Teradata has modified it to according to their standards. And then they named it as MPLAS. But currently, all of them have been migrated to Linux environment. So currently 90% of the clients run Teradata on Linux environment. SUSE and Red Hat. And the syntax and semantics, right, it is compliant with ANSI industry standards. So it's, the semantics, everything follows the ANSI nature, just like other RDBMS, which are ANSI standard. And Teradata, it runs on a single or multiple node. In the coming slides, we will see basically what's a single node and multiple node means. And Teradata, we call it a database server, where we can connect to multiple clients using a massive parallel processing architecture. So basically, Teradata is an MPP architecture. And currently, most of the large-scale systems like Vertica, Netezza, Big Data, Hadoop, all these are massive parallel processing systems. So where the data is being processed parallelly. And from Teradata perspective, right, parallelism is one of the best features it has, which can manage effectively humongous amount of data. If you look at the history of Teradata, right, it started way back in 1975. And its first product was released in 1979. And later, many versions have been released with new features embedded into that. And some of the major releases were happened in 2002, 2003, like V2R5, 5.1. Then later came V2R6, then TD12, TD13, TD14. From the user perspective, right, there will be nothing much difference from the feature to feature, unless and until a new feature has been introduced which deals with a new syntax and semantics. But most of the things will be common from release to release. There will be some performance improvement issues, and if any previous versions are failing with any syntax and semantics, they will be resolved in the higher versions. And each release has some thousands of features embedded into it, but these are one of the prominent features it has. Like in V2R6, collect statistics was a major feature introduced into it. TD12, query rewrite. TD13, scalar subquery and no PI. And in TD14, temporal feature and columnar feature. In the later part, right? Yeah.
I could not understand any of them actually.
No. Like suppose if you look at 2003, right? Like user-defined functions, binary large objects, and character large objects. So basically, binary large objects is like handling image files, HTML files, or pictures, those kind of things, audio, video files. And character large objects are huge HTML files, text files. So if you want to handle that kind of data in RDBMS, right, this feature will allow you. So earlier, those features were not there. So if you want to upload a 100 MB video file, earlier it was not allowed. But after that feature, it has been after this feature has been introduced, you can even append that into RDBMS, audio, video files, JPEG, MP, bitmap, and all those kind of files. That is treated as that binary large objects and character large objects features. Similarly, UDFs, user defined function. Like you can write your own function and embed it in the SQL. Some of the normal data processing, right, it can't be done through regular SQLs. Through SQL, you can't achieve it most of the time. For that, UDFs will be very helpful for you. Everything can't be done using a SQL. For those things, UDFs are required, which will help minimize the effort.
Okay.
And query rewrite. Suppose query rewrite. Query rewrite is like it is one of the best optimization feature internal to Teradata. Like whatever query you write, Teradata internally it rewrites into an optimal request.
Yes.
Suppose since
So that part I understand because I have gone through some of your videos. So I mean you tell about that, you know, it somewhere it creates an execution plan and then it fires into different nodes. That one, right?
Yes.
Yeah.
It internally creates a request, an optimal request. Suppose in simple terms, suppose if I give select star from T1, T2, I'm joining two tables with a condition x1 equal to x2 and x1 equal to 10. So Teradata, this is a request which has been submitted by the user. So same request Teradata converts into this one. So this is more optimal than this one. Both will return same results, but the second one is a good one. Is an optimal. It will perform more faster than the first one.
Oh, okay. Oh, I did not know this one. I was thinking that distributes the query in across nodes. So okay.
That is just request processing, basically distribution of the request. This is optimization, rewrite. This is your query. This is Teradata rewriting it into an optimal way. That is query rewrite feature.
Okay.
And similarly, scalar subquery, single row, single column, no PI, like creating a table without any primary index. Then temporal feature, like period data types. In normal data warehousing model, right, every time we deal with dates and timestamps. Period is the most prominent one. Like what is a period a customer is active? Start date and end date. It's a period. So that feature has been introduced in TD14. Apart from this, one more feature is there, columnar. Like general normal data storage is always row wise. Whatever data you have, you store it always in the row wise. But columnar feature is the one which will store your data in columns, not according to rows. It will store according to columns. Suppose if an employee table has 10 columns, employment number, employment name, address, date of birth, job, salary. So all the employment numbers will be stored as a single row. Then all the department numbers will be stored as a single row. All the employment numbers will be stored as a single row. So basically storing the data from column perspective, not from row perspective. That is columnar feature. We will see what is the advantage of it and how the structure is maintained if we maintain it in a columnar fashion. But just a high level, what all features are there. The two most prominent one.
Okay.
And this slide, it talks about the architecture of Teradata. The gray color box which you are seeing, right, this can be treated as a node. A node is a machine. So this is a single node. So if I install Teradata software in my laptop, right, then it acts as a single node. Suppose if I install Teradata in my machine, my laptop and your laptop, same version, and then I can configure both the machines into a single machine. Then it becomes a multi-node. That's the reason I said Teradata runs on single or multiple node. Last fourth point.
Yes, I got it.
So this is a single node machine, and these are some of the components which are installed in that single node. Parsing engine, message passing layer, access module processor. These components, parsing engine and access module processor, they are like virtual processors, not physical. They are virtual components. And parsing engine functionality is whatever request you submit to the system, it will check the syntax and semantics. Apart from that, it also has the ability to has the intelligence to distribute the data. This record to which AMP I need to send, this record to which AMP I need to send. So the parsing engine has that intelligence where exactly to distribute the data. And then distribution of the task. So whatever request you send, parsing engine will see from the syntax and semantic perspective, and then it will distribute that request to the AMPs to process the request. Message passing layer is like a communication protocol between two processes. So it acts as a communication protocol between parsing engine and AMPs as well as between the AMPs. Suppose here in this particular slide what it is talking is, so there are some n number of records, 12 records are there, and we need to insert into a single table. Okay, so what is happening here is one by one record or bulk number of records will be sent to the Teradata system. Parsing engine will see if the syntax and the semantics of the request are true or not. Excuse me. Then what happens is parsing engine will distribute the task to the AMPs.
Okay.
Or distribute the data across the AMPs. Then what happens is each AMP will process that data and it will store it in that particular disk. Now, and this is how the data got distributed. As I said earlier, parsing engine has the intelligence to distribute the data as well, and it has distributed in this fashion. In Teradata, right, parsing engine always try to, the main aim is to distribute the data evenly, so that the processing is evenly performed across the system. And now the distribution has happened. Now the user is
there.
Yeah, tell me.
Tell that it distributes the data evenly. It only distributes the data evenly, or there are some intelligence to distribute the tasks. Suppose I wrote a SQL query which has one subquery, 3 joins, and let's take this one simple one subquery, and it has got 3 subqueries and 3 joins. So will it that even distribution will be on the basis of query load, or it will be and there I have some 20,000 rows. So the even distribution, how it will be evenly distributed to 4 AMPs?
It mainly, right, data distribution depends upon the index you define. Suppose you have some employee table, department table, and then job description table. 3 tables are there. The distribution happens based on the index you choose. Suppose for the employee table, you choose employment number as the index. Then what will be the what is the nature of the employment number? They are mostly unique in nature, isn't it?
Yes.
2 employees can't have same employment number.
Exactly.
So if the data is unique, the distribution will happen in an even fashion. If the data is non-unique, then the distribution might be skewed. That means for employee table itself, if you take department number as a primary index, then what will happen? All the similar department number values will go to 1 AMP. So basically distribution happens based on the type of index you choose. The more unique, the more even distribution.
No, my question was not that. Okay, I mean, my query involves 4 tables: employee, department, project, and customer. Employee, department, project, and salary, and 1 fact table, 3 dimension tables, and 1 fact table. Okay,
fine.
And I have written a big SQL which has got 4 joins and 4 subqueries. Now, so and each table has their own primary index. So when I fire this query, which will go to, and I have a 2 node system. AMP1 and AMP2. Now, which one will, how much of that query will go to AMP1 and how much of that query will go to AMP2?
So you're saying a 2 node means one more node will be there. Similar to this one more node will be there. Okay.
No, I will only, okay, no, I have only 2 AMPs, AMP1 and
Okay.
AMP2.
You are using AMP1 and AMP2. Then what happens is, whatever the 4 table data is there, that will distribute across 2 AMPs. Employee table across 2 AMPs, department table across 2 AMPs, salary table across 2 AMPs, project table across 2 AMPs. Now, if you write a query which is involving 4 joins and 4 subqueries, what will happen is the entire task will be processed by the parsing engine, and then that task will be distributed to AMP1 and AMP2.
Okay. My question was, the parsing engine, when it distributes the task to 2 AMPs, it distributes the data or it distributes the task?
Distributes the
My
task.
question is,
whatever request you are sending, right, that will be distributed, because AMP is a process. Data is there in the V disk. If you see the down arrow, right, the last one here, this is the disk where the data is loaded. Okay. So AMP is a process which will perform the task on the disk. It's just like a CPU. Functionality of a CPU, you assume. The functionality of AMP is similar to the functionality of a CPU.
Okay.
So suppose if I assume this same request, select star from T1 comma T2, where x1 equal to x2 and x1 equal to 10 and x2 equal to 10. So this request will be submitted to AMP1 as well as AMP2. To both the AMPs.
Okay.
And then it will apply the conditions applicable to that. Okay. So basically in this case what will happen is, this x1 is equal to 10, right? This can be applied on table T1. And this x2 is equal to 10. This can be applied on table T2. And then later it can join with this condition. Join the 2 tables, T1 and T2.
Actually, I have one more question. I am sorry to interrupt you. So,
tell me.
I mean, suppose I have, on a typical data warehouse on a typical data warehousing project, I have 10 dimension tables. Customer, project, product, item, location, bill to ship to, something else. I have got 10 dimension table and 1 fact table. So, how does Teradata decide which table will go to AMP1, which table will go to AMP2? Or it takes every slice of data from each table and puts in all the nodes? Or it tells, customer table I will put it in AMP1 and project table will go to, product table will go to AMP2.
No, not like that. Whatever table you have, it will distribute across all the AMPs. Each AMP will be holding.
Suppose I have one table. Suppose I have one table with no rows. I mean, I don't have any rows in that table. So in that case also, it will create an instance of that table in 10 AMPs. Yeah, it will create the structure in all the AMPs. Empty table, it will create a structure in all AMPs. Okay, I got it. Okay, that answers my question. I got it. Thank you. In the worst case, what will happen is, if I have 10 AMPs and 10 records, at most each AMP will be holding 1 record. Okay. So whatever table you have, it gets distributed across all the AMPs. That's the fundamental behavior of Teradata architecture. Distribute the data across all the AMPs. Okay. I was thinking it is a table. I mean, there are suppose customer table is 100 records and product table is 200 records. So it is like in AMP1 and AMP2 will have 50-50 records of customer 1 and customer 2, and AMP3 and AMP4 will have like another 50-50 records of product table. So in one table only customer data is there. In one AMP, and the AMP3 and 4 has only product data. No, not like that. Each AMP will be holding a slice of that table. Okay. So each AMP will be holding a slice of every table. So that is the correct statement. Yeah. Okay. Thank you. I got it. Yeah. So whatever the task is sent to the parsing engine, it will distribute the task to
all the amps, and each amp will be performing that task, and all the amps will be performing that task parallelly.
Okay. Yeah, yeah. That you told parallelism, massive parallelism. I got it.
Yeah. So that is how the parallelism works in Teradata from top to bottom. Suppose if we take a scenario, two requests. You are submitting one request on T1 and I am submitting a request on T2. Parsing engine will take both the requests parallelly. Then it will distribute the task to 4 amps. Both the request 1 and request 2 to 4 amps. So each amp is holding now how many tasks? 2 tasks. One is of your task and one is of mine task. So totally each amp is holding 2 tasks and both the tasks will be run parallelly. Okay. And there is a limitation like 80 tasks. Each amp can run 80 tasks in a parallel fashion. And from parsing engine capacity, each parsing engine can handle 120 sessions. Suppose if you want to log on to the box, right? You need a session. So parsing engine will handle one session, yours. If I want to log on, I need a session. So parsing engine will handle even my session. Like that, one single parsing engine can handle 120 sessions parallelly.
One question actually on that. Actually, I have logged into Teradata only once or twice in last 2 days. So when I logged into that, in the SQL assistant, there are something like open 1 query, 2 query, 3 query. So that one you mean a session, or I as an individual user, like I can open some 10, I don't know how many, but I can keep on running, like, I can run 5-6 queries concurrently also in Teradata. One query is running and again I run another query. No, I just tried.
That is a single session basically.
That is a single session. So 120 guys can run. Okay.
One P can handle 120 sessions parallelly.
Okay. And one session can, how many tabs he can, how many SQLs he can write concurrently?
Suppose if there is any dependency, right, then it can't actually. If there are independent, then it will run one by one in that session. There is no limit how many SQLs in that session. You can run in n number of.
Okay, okay. No, I was asking concurrently, like how many tabs I can open in that SQL assistant window, because the number, I can open all the tasks and I can write queries and I can fire them at one go, right?
Yes. Limit, I don't think so. I don't know if there is any limit on that.
No, I just asked a random question. I mean, look, I don't know anything, so I am asking really nonsensical questions. Might be whatever is coming to my mind. I am asking.
There is no any design limit like that. On an ideal fashion,
why my question I am coming from somewhere?
10 to 15. 10 to 15 basically.
Okay, okay.
That is an ideal one. It shouldn't be greater than that.
So can I do it like this calculation? 120 sessions. Each session can have 10 SQL windows, or I can run 10 SQL queries from one. So at one time 1200 SQL queries can go and hit Teradata. More than that it will lock, or
it can.
No, so more than that, suppose I am using Teradata for a not exactly for a data warehouse, but suppose for a database for a e-commerce platform. So in Amazon kind of stuff, when there will be lot of people will be lot of people will be doing and querying the database. In those kind of scenarios, there will be hundreds of queries every time. Not 100, probably 1,000 or 10,000 or 1 lakh queries every second. So Teradata can handle those queries, or because you are telling it is 120 sessions and each session I can go for some 100, 50. So it is 18,000 queries maximum I can give, or it can be more.
No. Session, I mean to say, it's a connection between you and the client and the server.
Okay.
That is treated as single session, and in that session you run any number of queries. It is treated as only one session.
Oh, okay, okay. I got your point. I got your point. Okay, okay.
Okay.
Okay, I got carried away some other way. Okay. Go.
Unless and until you open multiple tabs and again specify your username and password, then it will treat as 2 sessions, second session.
Okay, okay.
Okay.
Yeah.
And in a real-time environment, right, since it's an MPP platform, we can configure more than one PE within a single node, like 10 PEs in a single node.
Oh, okay, okay. So what do you mean? We can configure, it will be configured by Teradata, right?
Like,
or I can go and configure?
No. When Teradata is being installed, right, at that time we do the configuration.
Oh, okay, okay. That is what DBAs might be doing, right?
System DBS, not even the application DBS. The system DBS will do that.
Okay, okay. Okay, okay.
Any other questions, Deepak, on this?
No, I'm good. I have asked too many questions already. So, thank you.
And then coming to, as terabyte, it has been derived from Teradata, 10,000, 10 power 12 bytes, we call it as a terabyte. And these are some of the common differences between Teradata and other RDBMS. Most of the differences currently will not be holding true, because even other RDBMS are coming up with a similar kind of architecture. Like Oracle came with Exadata, IBM came with Netezza. So even
I worked in a project where there was Greenplum actually. So
Greenplum, okay, fine.
They also have massive parallel processing, and they also have a columnar index. I mean, Greenplum also has. That is what they tell. Like,
yeah, the architecture is almost similar to Teradata nowadays. Most of the
I don't know the architecture because I was so, but I know.
Yeah, that's why most of the differences currently now might not hold true. But this is a major difference between Teradata architecture and other RDBMS. Like Teradata, we call it as a shared nothing architecture, and whereas other RDBMS we call it as a shared architecture. Why? It means here, if you see, each AMP is holding is associated with a disk. Each AMP is associated with a disk where the data is getting stored. So this disk will never be shared across any other AMP. That is shared nothing architecture.
And how does it help actually in query performance? I mean, ultimately, database thing is performance. So how does it shared nothing architecture helps?
Like we are not allowing multiple processes to access the single data at a time.
But then you have the task of joining them at a later point. My query, I mean, whatever the records coming from AMP1 and what is going from AMP2, you need to join and give me the right result, because I don't know what is AMP1 and AMP2. Suppose I am a, SQL query writer.
Yeah. So in Teradata, right, since we have distributed the data across multiple AMPs, right, and if you want to perform any join, then there are certain distribution techniques internally which it happens, redistribution and duplication strategy, that will be helping in performing the join. And in the worst case, a product join, which is a very, very worst case, which we never encourage actually, product join to happen. Okay, but other kind of joins like inner join, left outer join, right outer join, full join, they happen.
What is product join? What is that?
Product join means each table needs to be joined with each, all the records in table 1 need to be joined with all the records of table 2. That is product join.
Oh, okay.
In real time, that will not serve any purpose most of the time, the product join. That means you are missing some conditions.
Yeah, definitely. I mean, if all the records in one table are same joining, then it should have been ideally one table. What was the need to create two different tables actually?
Yeah, that's true. So only that is that typical or in the worst case basically, a product join to happen. Other than that, other joins happen very effectively within the Teradata environment. Join is almost considered to be a costly operation, but still it is fine in Teradata environment. We can effectively perform the joins with a short span of time.
Okay.
And then one more difference is the index usage. Like since we are seeing the distribution of the data to be even, right? That is because of index, because of creating a unique an index which is even in nature. So in Teradata, index is for both a better storage as well as for faster retrieval. Okay.
So when you are pushing the data, when you tell better storage, when you are pushing the data, also creating a table and putting the, I mean, suppose I am inserting the records at that time, or I am creating an index. What is I mean, because I am not getting that. What is the index for better storage?
That will decide actually where the data needs to be stored. The index will decide.
Okay.
Suppose.
Oh, so suppose I inserted 20,000 records.
No, suppose
go ahead,
take an
sir.
employee table. Take an employee table. Okay. And which column you will choose as an index? Assume there are 4 columns: employment number, employment name, department number, and salary. Okay. Which column you will choose as an index? Primary index mostly.
I will go for employee ID. Yeah, employee
ID. Okay. Why? Because that will be more unique in nature.
Yes, correct.
Okay. Okay. In Teradata, they have designed an algorithm called hashing algorithm. That algorithm will take input value as a primary index value. Based on that, it will distribute the data. And the algorithm is so powerful that if the data which you send to that algorithm is unique in nature, the distribution will happen in a given fashion.
Okay.
Irrespective of the data type. It can be any data type: date, time, timestamp, integer, decimal, char, varchar, anything.
Okay. Okay.
If the data is even, distribution will happen in a good fashion, even fashion. That algorithm has that intelligence. That is part of parsing engines. That's why I said parsing engine has a syntax, semantics analysis, as well as data distribution intelligence.
Okay. Okay.
Way to distribute the data. And the input is index value. So which column you choose as an index value, that will be helpful in determining the distribution.
Okay.
And from Teradata RDBMS capacity perspective, right, it can handle millions of instructions per second and process terabytes of data. And parallel processing, as I said, it is the main feature of Teradata RDBMS, which works effectively than other RDBMS systems. And it's a, it's a single data store and can be accessed by 2 types of client systems: network attached system and channel attached system. Network attached system is like regular operating systems like Windows, Unix, Linux, Solaris, all those comes under network attached. Channel attached is the mainframe, mainframe client. And fault tolerance, it can automatically detect and recover from some of the failures in Teradata environment.
So do you mean that it takes the backup immediately, or some internally it keeps on taking some backup so that it will, from there it will restart?
Yeah, some of the internal failures or some of the vprocs, if it fails, right, still the recovery of that happens, or the process happens, or the data happens. Later in the recovery protection mechanism, we will see how that happens with the help of a journal. And data integrity, similar to any database, even Teradata provides data integrity. That means any transaction, if it happens, either it ensures that it is complete, or it ensures that it is rolled back to the previous state. Okay. And then scalable growth, like the Teradata allows the expansion of the system without any performance drop. And SQL is the one which is the standard language which is used to access the Teradata server.
Okay. I have one question there. Is that TSQL or it is Teradata SQL called TSQL or something?
No, no, no.
It is a normal ANSI SQL you told?
No, no, no. TSQL is a Transact SQL. It's a different one.
Oh, it is not Teradata
No, no, no. It's
SQL.
not Teradata.
Okay.
It's a Transact SQL. It's a different
Okay, so
kind of.
Teradata supports the ANSI SQL.
Yeah, ANSI standards.
Okay.
T-SQL is for different database, not for Teradata.
Oh, I thought no. I thought I have got it wrong. I thought Teradata is like T-SQL and green plum is like G-SQL. That is
No, no, no. T-SQL is altogether a different kind of SQL database. Transact SQL. Mostly in the real-time transactions, it depends. Like the syntax and semantics is more similar to a real-time transaction environment. Insert, update, delete with the small values, not for complex query processing. Okay. Like suppose in the real-time environment, if you see some transactional data, right, what it will be? Insert one record, isn't it? Delete one record or update one record. Small sequence. A data warehousing, it's a complex sequence. You do multiple joins, nested levels, subqueries, correlated subqueries, data tables, all those things. T-SQL is a simple insert, update, delete kind of a framework. Transact SQL we say.
Okay, okay. Thanks, Simon, for telling me that. I was thinking that Teradata SQL is T-SQL. Yeah.
Any other questions up till now, Vivat?
No, I'm good. I mean, I'm asking you, whenever I have a doubt, right? So.
Yeah, that's fine. And from the training perspective, right, some like the other models which we'll be covering in the later part and of this one, the Teradata architecture and components, a little bit in detail, what exactly each component does. Okay. And then the protection mechanisms in Teradata. What are the different kinds of disk level protection, what are the different types of system level protection, how we protect the data, how the data integrity is maintained, those kind of stuff. Then comes the technical part, the different indexes in maintained in Teradata, and then comes the DDL, DML and the DCL part, different manipulation statements or the definition or the control language statements. Then some basic functions which are available in Teradata, those things will be seen, and then the different types of join strategies and types, how join types are given and how basically they are executed in Teradata environment, internally how they are performing a join. Okay, so we will look into that as well, and then some external commands which are available in Teradata. And then comes the various kinds of objects available in Teradata, macros, triggers, procedures, those things. And then a little bit of DBA part, this one, memory spaces and managing the database. Why? Because since we'll be working real, we'll be practicing hands-on, right? We need some DBA knowledge as well, like creation of a database, user, granting access, right? Creating some space, removing some space, granting authorities or access rights. Those things. For that part, we will be learning this DBA part as well. If you don't learn this one, right, then it is difficult to practice hands-on in the lab. That's the reason we'll be covering this part as well. This is a very simple one, not that complex. And then the various types of transaction modes available in Teradata, and then the performance tuning. What are the best practices which are need to be followed in Teradata environment? Suppose given a requirement, right, you can frame the sequels in 100 ways for a given requirement, isn't it?
Yes.
But
yes.
Only one or only few will be a better one. So how to frame those sequels? What are the better standards we need to maintain when we are writing in Teradata environment? What are problems will come for the other scenarios? Those things we will see from the performance tuning perspective. And then later comes the production support utilities, the BTEX scripts, then the fast load, multi-load, TPUM, TPT, how we can perform the load unload job, what are the different real-time failures will happen when we run these jobs, and how do we recover, or how do we handle them, the error scenarios. Those things we will see here, the production support job, utilities. And then once we are done with that, then we will look into the additional features which have been introduced recently. No PI, scalar, subquery, temporal, columnar, those things. Syntax, semantics, and some sequels related to that. Then apart from that, I will be providing you some materials which will be helpful for your Teradata certification as well, basic and SQL. You can even go for PI as well, 3 levels, up to 3 levels we can finish it off.
Actually, how difficult are these certifications? Because I was reading in some blogs that now they have become very difficult actually.
Yes, actually. Earlier it was fine. TD 12 it was fine, but later on they have been like it's becoming more difficult and difficult. The basic reason is the materials will not be that easy to get it for those latest versions, and the what we say, the modules which are included in the certification are not that clear. Sometimes most of the answers also related to that each and every topic, right? It causes ambiguous. We will not be that sure which is correct. That's the reason it is becoming more difficult and difficult day by day.
Okay.
Earlier it was not that difficult, but yeah, as you said, TD14 it's becoming a little bit difficult.
Then can I go and write the 12, or the 12 certification is no longer there? They have fetched it out.
No, still it is going on. 12 they haven't removed it yet.
Okay.
Are you sure?
12 will be easy, right?
12 will be easy. You can, once the training is done, you can easily write that 12.
Okay. Because I don't have much experience, right? I have only gone to the Teradata. I mean, last 2-3 times only I have logged into that.
Okay, fine. Yeah, TD12 is fine. No issues with that. TD14, yeah, it's a little bit difficult. We can't take a risk at this time. Because we exactly don't know even the modules. Which modules are exactly covered in that.
Okay. Yeah.
And generally it's not like a single multiple choice answer. Each question might have 2 to 3 answers as well.
Yeah, I know. All certifications are like very tricky.
That is causing one more issue. And
so
we will be working on...
we will be able to go good with the TD12 at least.
Yeah, certification is TD12, but we will be working on TD13 environment.
Okay.
13 Windows, and for few topics we will be working on TD14 Linux environment.
Okay.
And you can also easily download the TD version 13 or 14 Linux one. Okay.
No, I have that production thing, so I can use my office laptop to create a temporary. I mean, create a temporary table, and I can do something.
That's fine. But some of the scenarios it's not viable to use it in a production environment, right? Like some test cases to create some product joins, do a job failure, those kind of things. So it's better. It's a very small package, the demo version. I will show you how to get it from the Teradata website. Okay. Simple installation on a VM package, on a VMware.
Okay.